you seen my
Ah,
presentation on the screen, sir?
ಕೇಳಿಸ್ತೆ ನೋಡ್ತಾ ಇದ್ದೀನಿ.
Okay, fine.
So let me welcome everyone.
Sir, I will wait. Can we start, sir? Alok, sir, can we start, or whether we even wait?
I think let us start. Let me introduce the speaker.
Yeah, please, please.
Hello, sir.
Yeah.
Yeah. Jaldi,
Yeah,
madam.
please. Yes, sir. Yes, sir. Please record the session, sir, because I have joined through mobile.
Record ಆಗ್ತಿದೆ ನೋಡಿ. Record ಆಗ್ತಿದೆ, madam.
Okay, okay, sir. Thank you. Thank you. Go ahead, please.
Okay, now almost more than 86 participants joined. We'll see.
93.
Yes,
Yes, sir. Yes, sir. Yeah.
Okay. So let us start. Good evening, everyone. Let me introduce the speaker, today's speaker, Mr. Vijay Mahantesh. He has 16 years experience, professional experience spread across industry and academia. Currently, he is a managing director at Cleverbit Solutions Private Limited, Bangalore. He was associated with various organizations as consultant trainer. He has worked in semiconductor industries like National Semiconductors, CVC, Masam Electronics as design and verification engineer. He has also worked as faculty in engineering colleges both in India and abroad. His areas of interest are C, C++, Python programming, embedded system and Internet of Things, front-end VLSI designing. He has got a BE degree in instrumentation technology from VTU Belagavi, and he has done his MS in VLSI CAD from Manipal University. In his career, he was involved in front-end verification of ARM core processor, design and verification of network on chip, front-end verification of embedded protocols, I2C and other bus protocols. He has conducted various workshops on programming and embedded system designing. He has trained over 10,000 students on programming. He successfully guided many students to carry out their academic thesis at both UG and PG level. Mr. Vijay Mahantesh, I am really grateful to have you in our today's session. Please continue. I'll hand it over to you. Thank you, sir.
Yeah, thank you very much, sir. Indeed, it's my pleasure to be here. Okay, very good evening to all. I hope I'm audible as well as you can see my presentation on the screen, right? Should there be any concerns, please do let me know. So maybe you can put in a message in the chat box so that I can read them and then try getting back to you, right? So, so let us begin this little, session that we have taken. So that is basically, it's a titled as Getting Started with Embedded System, right? So why this, topic called Getting Started with Embedded System, right? The reason is very simple. As an engineering student, many of us, basically have some kind of thinking happening that, okay, maybe I want to, start learning embedded system, but where should I begin or how should I go about it, right? For that matter, it's not only applicable to embedded system. For that matter, it is applicable to every field that is involved, right? As a student, there is always this ambiguity involved, indicating how should I go about learning a technology, or basically where should I start from, right? So the whole objective of this webinar is to guide you where to start learning the embedded system, or maybe I can give you a little bit of hands-on so that you understand, that there are various tools available, so only thing that is required to learn is investing the time rather than anything else, right? So with this, little introduction, we will begin our session on embedded systems, right? So to begin with, let me ask you, a question, right? So what is an embedded system is? How many of you are aware? So I'm not sure if you can hear me well. If that is the case, can you just put me a message in the chat box? Sir, is the chat box enabled as such?
Yes.
Okay, okay. So dear students, right? So can somebody let me know what an embedded system is? Right? You can always put a message in the chat box so that I can read them, reply to them, right? So no messages as such. Okay, okay, that should be fine. Okay, I got one, right? So computers embedded within a bigger system, combination of hardware and software. Now I see, right? So the messages are popping in. So very, very good thing. So I just love the spirit, right? So good going, right? Manjunath says it's a combination of hardware and software, right? So rightly put it across, Mr. Manjunath, right? So to tell you, embedded system is basically a system that is designed using hardware as well as the software to perform a specific task, right? Here we use the term specific task, right? So there are something called as generic systems and there is something called as a embedded system. An embedded system is something which is always designed to perform only one activity, whereas a generic system is system that is capable of doing, right, many other activities, right? So if you see on the screen what I have here on the left side, I've got this hardware diagram. So maybe if you have a look at it carefully, you can see that there is DAC, there is ADC, there is amplifier, there are counters, filters, timers, or something that we have learned as an electronics engineer, right? So it's not only this. In fact, it is much beyond this. But for the time being, we will understand this as nothing but hardware components, right? Then on the right side, if you see, I have written this as a plus, and then on my right, I have this little piece of statement that indicates that it is a programming, right? It is basically a program that is written in C, right? So in order to take on embedded systems, I need to be good in two things, that is the hardware components as well as the software, right? Or basically the programming languages, right? The question is, which language should I take up, right? So I will answer that very shortly, right? So we'll do a couple of hands-on as well. So as of now, remember, embedded system includes hardware as well as the softwares now, right? So if I have to give you a simple example about embedded systems, the popular washing machine that everybody has in their home, right, is one simple example of an embedded system. If you look at washing machine, it always does only one activity, right? It is meant only for washing the clothes, right? So in that case, it is an embedded system. So see, embedded system can be very simple. At the same time, it can be a very complex system involving a lot of computational powers, right? Such as complex robots, right? So that way, it depends upon what kind of application we are doing and what kind of so hardware design need to be done, right? So this is embedded system at its simplest form, right? So now, so what are the applications or where I can use this embedded system? Typically now, if I have to tell you, so you just look around yourself and see anything that is happening around you that makes use of the embedded system, be it the, the cell phones, the cameras, the printers, the automobiles, the robotics, the gaming console, the cameras, the television sets, everything right around us is just an embedded system, right? That means we are surrounded by lots of embedded devices around us, right? So that basically tells us a story that embedded system is just present everywhere. So that way it will offer us a lot of opportunities once we get to understand what an embedded system is, right? So this is a little about the applications, right? So now coming back to the objective of this session, where should I begin? All right. So how would I start learning embedded system? It is simple, right? So start working on C programming, right? So it is a good language to begin with. Then possibly, these days we have some simple microcontrollers available at a very, very low cost. So one such controller is basically the Arduino board, right? So what we need a C programming, right? So we need to be good at C programming. Then I can take up something called as a Arduino board. And then, as I told, we need to design hardware. So that can be done using some simple electronics components, right? So with this little combination, you are good to go as an embedded engineer, right? So as I told, basically this session is, this session is going to be a hands-on session where we will, start working with C programming to some extent. I assume that all of you have the basic idea about C programming, not to a greater extent, because we are not doing something which is complex. We are just, trying to get hands-on of the embedded systems, right? So then as we go along, we will try to understand a little bit more about the Arduino systems. Then we will try to understand few electronic components as well, right? So as I told, what we need C programming, then the Arduino board, and then a set of electronic components, right? With this, we are just good to begin the session now, right? So then I call it as getting into embedded development. Now, so due to COVID, so we are not going out. So I think now things have aged a bit. We are lucky that, things are getting improved and we are allowed to go out, and you as a students are allowed to go to colleges, right? So otherwise we had a very, very tough time. So where, everything was shut, we are not able to get the hands-on experience on your laboratory experiments, correct? So now that is gone. So even despite that, so is there anything where I can learn this embedded? I can learn coding, or I can get a hands-on of experience on these components. Yes, you can do that without actually buying these components. You can learn these things, and possibly if there is a chance, you can after learning you can get the components and then try to just mimic what you have learned online. Into that you will be able to learn it well, right? So without wasting much time, so let us try to get into this particular thing. What is that? So we need to log into a website called Tinkercad, right? So Tinkercad is basically, online facility provided by a company called Autodesk. So that will allow you to learn the programming as well as working with the Arduino now, right? It is a very, very simple tool to work with. At the same time, it is very, very effective when it comes to learning embedded systems, right? So what do I do? So typically we need to just create a login ID and password. You can just sign up for this. Once you sign up for this, then possibly you can easily work with this, right? I will give you a little demo about, so maybe assuming that all of you know how to create a login ID and password, then so we will start working with this, right? So I repeat again, the name of the website is Tinkercad. You can see here I have written it as, so the Tinkercad, right? So tinkercad.com. Just need to create an account here, right? You just need to work with this tinkercad.com, and then we are good to go with the Arduino programming, right? So with that, let me take you to the Arduino dashboard, right? So once you create a login ID and password, when you log in, this is how your dashboard will look like, right? So under this, what is that need to be done? So if you notice to the right side, we have something called as circuits there, right? We have something called as circuits. You just click on that circuits here, right? So you click on that circuits, you can see that, a window will pop up. Then we can begin working on that, right? So you click circuits, and then once you see circuits, you can choose this option, create a new circuit, right? You just need to follow the steps, and also remember that. So after the session, I will share you this document. You can possibly have a relook at it, and then you try working on this, right? So can everybody see this website tinkercad.com on the screen?
Yes, sir.
Right? So I need this little acknowledgement all the time, because since it is online, it's very, very difficult whether you are able to see the screen properly or you can hear me well. Yeah, a little thumbs up is always a good, right? I enjoy this thumbs up a lot, right? Maybe you can do that. So as in when you like something, you can always clap, right? So that we can do, right? So what we have here is we have logged into a website called Tinkercad, right? We have logged into a website called Tinkercad, so which will basically, give you a, a online tool to learn the, embedded system programming, right? So what is that we have?
Yeah,
So
yeah,
I
बकवास है यार.
request, I request
हाँ?
Rohit, we kindly mute
What
yourself.
subject में mistake अलग यार.
Rohit,
Hey,
okay, so I will mute it from my end. Okay, so So maybe I think you can just post a message. So later I will enable your microphones. You can possibly then talk to me. Otherwise, so this unwanted noises will creep in, right? So what we have here is a tool called Tinkercad. So it is very, very easy to work with this particular tool. Now all of you can see this blank, a white space here. And if you notice to the right of the window, you can see there is something called as a search option, right? So what we get here is, so since we are working with Arduino, I will write it as Arduino, right? So you type Arduino here, you can see a board coming into the list, and you can just click on this Arduino, and then you can drag this particular component on the area we see. We call it as an editor window, right? So this is where we have got Arduino now. So now, so Arduino is basically a microcontroller. If you notice, so it has got these pins numbered as 0 to 13, right? So there are 14 pins in all, right? So all these are, right, basically the digital input output pins. That means you can use them as input as well as output pins, right? So you can use these pins as input as well as output pins. And also you can notice, so you have these pins numbered as A0 to A5, which are your analog pins, right? So then there are power pins, right? So V in, ground, and there is a supply of 5 volts, there is a supply of 3.3 volts, and then reset button and all other things. So in this session, what we need is, we don't get into the every single detail about the Arduino board, because we don't have much time, but we will try to use the Arduino in such a way that we will end up getting some information about the Arduino now, right? So if you notice here, so it is numbered as D0 to D13. So there are 14 pins which can be used for input outputs, or in fact, which is used for digital input outputs, right? So now what I do here, so we will try to work with something here, right? So now try. So this is an Arduino board, right? So as I told, it has these power pins, 5 volts and 3.3 volts, and also it has ground. I can use these pins as a power source, right? I can use it as a voltage source. So what we mean by this, right? Remember, Arduino is capable of providing you 5 volts and 3.3 volts to work with the circuits now. So see, remember, I have not written any code as of now. I just want to use these pins of Arduino, so it will act as a voltage source. Now, how do I know it? It is acting as a voltage source. Let us go to the search component box. Then I will pick up something known as a LED here, right? So I will pick up something known as a LED here, right? So you can notice this is a small LED with the two legs, one written as cathode, the another one is written as anode, right? So what I do is I will pick up this cathode pin, right? So all you need to do is, in order to make a connection, you just need to keep your mouse pointer on this pin and then click once and then start dragging. It will give you a wire connection. So what will I do? I will connect it to, uh, ground pin here. So what is that? So grounding is done with respect to the LED here. Then I will pick up one resistor. I will connect it to the anode pin of LED, and maybe you can keep it very small. So I would use it as a somewhere around 330 ohms, right? So then this pin can be connected to the power supply. So right, very much what we have done in our basic electronics, right? So I'm connecting 5 volts to the anode pin, and then the cathode is grounded. Now remember, we have not done any coding. I just want to show you that this pin will be supplying 5 volts. Now what will I do? If you look at this right side, right, just above the component, there is something called start simulation, right? So what do you mean by simulation? It will basically mimic the actual hardware here, right? So I will call it as a simulation here. Now check. So can you see this LED glowing here? Right. So you can post a message in the chat box so that I can understand. So can you see a LED glowing? You can just give me a thumbs up, or you can just say yes, right? See, you can see this LED glowing. So that means, see, without even writing a code, if I plug in my Arduino to my computer, it will start giving me this 5 volts, right? That means I can use it as a power supply now, right? So I'm getting this now. So this one. So anytime I want to, generate this 5 volts power, I can directly take it from the Arduino. Now, so what will I do is I will take you to a coding part of the Arduino as well, right? So how do we do it, right? Simple. So now just remove whatever we have done here, right? So I will just get rid of this LED, I will get rid of this resistor, then I will basically start coding here, right? So before I code, I want to, create a small application here. What is that, right? So what will I do is, see if you notice in the previous example, I have taken the LED directly connected to power now, directly connected to power. That way it is glowing. Now what I do is, I will provide the supply to LED through programming. I will supply this power to LED through programming, and I will decide when do I want to turn this LED on. Then I will decide when this LED should be off now. So what we can do, so try to understand this, right? So as I told, we have this, digital input pins D0 to D13. There are 14 pins. What will I do? I will pick up this resistor, right? So I'll pick up this resistor. What I do here, so the cathode pin, which should be always grounded, I will connect it to ground. Correct? I will connect it to ground. And maybe if you notice, see, you have these color, wires here, color wires here. So I will always prefer, taking the ground in black color. So I make this color as black, so that anytime I see something in black, that indicates that it is a ground connection, right? And similarly, what will I do is, now notice, I will take this anode pin and I will connect it to one of the digital input output pin of Arduino, right? So you can pick up anything. You can pick up any pin from D0 to D13. So I am as of now doing it at pin number 13 now. So what will I do? I will change the color indicating that. So this is where I'm supplying my power here, right? A connection is done. So this is a simple program where I try to control the LED from the programming of Arduino. Correct. So now, where do I write the program? Where do I write the program? It is simple. Now we on the list of components, if you notice here, there is something called as a code. Click on that. Just click on that. So that will, open one, toolbox, and there are various options. So there is something called blocks plus text. We will go for text because we are writing the code. In that case, we will pick up the text form of the editor. So it asks you a message to, whether you want to write the text, you just say yes, continue, right? So by default, there is some code. I will not use this. I will just delete this, right? So we will build everything from the scratch. Remember that in order to work with the Arduino, right, we basically need to make use of two functions by default, right? Every single Arduino application need to have these two functions. What is that, right? First, try to understand. There is something called wide setup, right? So then followed by wide here. Wide setup followed by wide. So this is one thing. So this is a function now. If you have learned a bit of C programming, you must know what is a function is, right? So this is a wide function, wide setup function. And below this, I will have one more function called loop here, right? So I will take this as a loop. So even if you don't understand much of C programming, that is okay. So you just see what is that is being done. You will be able to write some good program on Arduino here, right? So wide loop. So remember, I need to use these two functions for every single program that I write on Arduino. So to tell you the first one, what is it now? Remember, so setup is nothing but identifying the input and output pins. Identifying the input and output pins. Now, if you have to tell you, so is there any pin that I'm considering as an input or output pin? So now look into these digital pins D0 to 13. So which pin I'm using? I'm using pin number 13 now, right? I'm using pin number 13 here. I need to indicate the pin number 13 that I'm connecting my LED to. Is it an input pin or an output pin? I need to make this decision here, right? So I need to make this decision here. So the anode of LED is connected to pin number 13. Then whether the pin 13 of Arduino is input pin or output pin. Remember, It is an output pin because it will supply power to my LED, right? So LED is receiving its power from the pin number 13 of Arduino. So pin number 13 is supplying, it is giving out, right? The voltage to Arduino. In that case, pin number 13 is what? It is an output pin. So in that case, I will write this as pin mode, right? So what is number 13? So what is it now? It is an output port here, right? I hope you are getting this. There is only one pin that is used. So ground is not treated as an input output pin. So because it is just a neutral pin where you can make the connection to this, right? So wide setup. So I'm setting up which pin? Pin number 13, right? As a output pin now. Remember, any display, any buzzer, so that you connect to Arduino is always taken as an output pin because they need current from the Arduino board. So pin mode, remember it is a single word written together. So where pin is written in lowercase and the next word mode, M has the uppercase letter, right? So pin mode 13, it is an output pin. Now, then what will I do? So this is my initialization. I will basically declare my inputs. Then the logical part, I will write it inside. Loop means what? Something that, runs all the time. Something that runs all the time, right? So now what I do here, I will write my logic. What kind of logic I will write? Now write on this time. So I have connected this LED to pin number 13, right? So I will decide when this LED to be turned on or off. As of now, I will do only one thing. I will just turn this LED on. So what will I do? I will write something like this. Now notice, so digital write, right? So digital write, what it will do? It will basically put a value of 0 or 1 on pin number 13, right? So basically you can use it to write a value of 0 or 1 on any of the pins that are there on Arduino written as D0 to D13 now. So which pin I'm using? I'm using pin number 13 here. What will I do? I will write a value called 1, which is written. So high is nothing but a value of 1, right? Whereas low is nothing but a value of 0. So what is that done? So I have taken the pin number, I have decided which pin I'm using, then I'm writing my logic here. Logic is what? So I'm deciding what is that need to be sent to the LED here, right? So now what will I do? I will run the simulation. You just need to run the simulation here, right? So can you see the LED turning on here? Right? You can give me a thumbs up in case if you are able to see this. Can you see this, right? A small LED, turning on here. The LED is turned on, right? So LED is turned on. And if you notice, LED has turned on. And next to that, there is one warning written with the exclamation, right? So what does that in program? Okay. So maybe, so programming related questions as we go along, I'm sure you will be able to understand them. As of now, just remember that. So in wide setup, we will choose which pin we are using and we will choose the mode here now, right? So what I have done here is I have chosen pin number 13 where the LED is connected. And since the Arduino supplies the current to the LED, in that case, it is taken as an output pin of Arduino. From Arduino, it is output pin, right? So from Arduino's perspective, it is a output pin, right? So if you notice, so there is one exclamation sign. Read out the message, what it says. It says current through the LED is 52.3 milliamp, while the recommended maximum is 20 milliamp, right? See, there is a restriction now. So what is the current that is going through the LED is 52.3 milliamp, but what is required is only 20 milliamp. So now you need to reduce the current. How do you reduce the current? Right? We are all, I hope, many people who are joined the session have a bit of, fair bit of idea about electronics, not to the greater extent. At least if you have studied something called as the Ohm's law, V is equal to IR, correct? So now what has happened here is this Arduino is supplying, the voltage is fixed, that is 5 volts. Now, so there is a requirement of 20 milliamp. My voltage is known, my current is known, then I need to, find the value of some component. What is that? Resistor. So resistor basically, is used to reduce the current, correct? So what will I do is, so you can always check this. V is 5 volts, current is 20 milliamps, and accordingly you can calculate the resistor value, and you can connect one resistor in this particular leg here now. So I will remove this, right? So I will remove this. So for that, you can stop the simulation. You can remove this wire, and then so go to your Arduino select component selection. You can just choose this. So pick up one resistor. I will connect it to the leg of anode. And what is the value I need, right? You can use this Ohm's law. V is equal to IR, right? So I think maybe since the value of voltage is 5 and then current is 20 milliamp, you can choose a resistor which is as small as 250 ohms now, right? So the moment you write any value, so you can pick up a resistor of any value here. So you just need to pick up this unit. I will pick up this as ohms and make it as say somewhere around 300, right? 250 is the minimum resistor that you can have. And then through this, I will connect it to pin number 13. Now remember, I have not changed anything in the code. I just modified, this anode connection. I've just included one resistor in between the anode pin and then the pin number 13 of Arduino. Then start the simulation again. Check if it turns on and also that little warning is gone or not, right? Yeah, now the LED looks green, right? It looks good now, right? It's not green, in fact, it is red. It looks good now. The warning is also gone here. So maybe if you are very fond of, the color and all, you can always pick up various kind of, the LEDs here. You can make them as red, green, blue, whatever you like, right? So that way you can make the now. So this time we are controlling it through the program. We are not directly taking it from the Arduino. And now, can I now make a modification to my program such that for some time the LED is on, sometime the LED is off, right? So we call it as a LED blinking program, right? We call it as LED blinking program. So for that, what will I do? So I'll stop the simulation, go to my code, right? So I repeat again. So first function is a setup function, which is basically used to identify my input and output for the application. Then the loop, which will basically determine the logic now, is used to include the logical part so that, you get some functionality of it, right? So digital write is a function which will either set the particular pin to high or low, right? So pin number that I'm using in my application is 13, hence I'm writing this as 13. And the value that I want to write is 1 now, right? So now what will I do? So I will include some delay. I want this LED to be on for some time, right? So there is a function called delay, right? So what will I do? I will include, this 2 seconds delay, right? So remember by default, the unit of this delay is millisecond. So that way you can always convert it in terms of seconds now, right? Delay for 2 seconds, 2000 milliseconds. Then after this delay, what will I do? I will say digital write. Just change the value from what? On which pin I want to change? I want to change the value of pin number 13 to low. So remember, high indicates 1, and similarly low is a preprocessor directive used to indicate low now, right? So and also notice since this is a loop, right? It is a cyclic statement. Immediately after this statement is executed, we re-enter the block and this digital write 13 high will be executed. So in that case, what should happen here is, so it will happen such that you can see the LED turning on, then delay, then goes off, and immediately you will again encounter the statement high. So it goes in a cycle. So for that, what I need to do is I need to include this delay at the bottom also, right? I can just make this delay 2000. Now check. Just run the simulation, check what happens to my code, right? It starts to blink, right? So for 2 seconds it is on, for 2 seconds it is off, right? So this goes on. Is it fine? Are you able to get this? Right? A simple thing, right? So what we have a setup function, loop function. Setup basically identifies your input output, and then loop, it will basically give me the logic, right? So it will give me the logic now. So you see, with this delay function, you can determine how long you want your LED to be on and how long you want it to be off, right? So assume that now I want to keep it, off for 5 seconds. I want to turn it on only for 2 seconds. What is that I need to do? So it is anybody's guess, correct? So it is anybody's guess. You just need to do this, right? So keep your LED on only for 2 seconds and keep it off for 5 seconds. After every 5 seconds, the LED will be turned on and it will remain for 2 seconds, right? So now run this. So run this. What will happen? See, it is on 2 seconds. Then it goes off for 3 seconds. And also you can check here, there is something called as a simulation time here on the screen, right? So you can see the simulation time here. So that is basically running in seconds, right? For 2 seconds, the LED is on. For 5 seconds, the LED is off now, right? Right? So I hope everybody is okay with this. Is it fine? Okay, right? So I see a good number of thumbs up popping on my screen. It is always good to see those things, right? So that is always good to see these things. And at the same time, so any questions, you can always put it in the chat box. Any questions? Any questions? Arya Thomas, right? Manav Bhatt, so Geet, right? Any questions as such, you can always put it in the chat box. Way to learn coding. Okay, so I don't know who is asking this. Way to learn coding, Skanda Raghavendra, right? So there are various ways to learn coding, Skanda. So way to learn, I cannot, assure that where you can go and learn. So you can always, look into your, curriculum. I think maybe C is there for everybody. So in the first or second semester. So to begin, coding, so that is fair enough. You can always pick up any book. So if I have to tell you to refer a book called Yashwant Kanitkar, right? Let Us See by Yashwant Kanitkar. It is a simple book, so maybe not the right book to become a good at C programming, but it is a better book to begin C programming. And later again, so as you start understanding the concept of Let Us See, then you have to read out a book called Dennis Ritchie by the founder of the C programming language. I haven't seen a good book than the Ritchie. So Ritchie is one of the finest book that is available on C programming. You can do that, right? And these days, there are so many platforms where you can learn coding, irrespective of which language it is. You can just do Google and you can learn so many things. But it is always better that you pick up one language rather than going through every single programming language. Pick up one. So that I would always recommend that you start from C programming, then gradually you can move to other programming languages, right? So I hope, Skanda, that is fair enough, right? You can pick up something and you can start learning. Okay. Now, any other questions? Right. So if there are no questions, okay, we will continue for some time again. Right. So now see, what we have here is we have only one LED. So what if I have to control few more now? Can I do it? Yes, of course you can do it. So what will I do? So now try to understand here. So what I can do here is I can possibly uh, connect a few more LEDs here. Then we will try to check here. So what will I do? I will pick up one more LED. So then what will I do? Again, the same thing. I can do it. I can connect this cathode to another cathode. You can short them. You can put it in black. Then again, this anode, I will connect it to one more pin. So this time I want you to, join me in writing these two functions, the setup and the loop, right? So what is the value of this? We have seen that this can be a small resistor somewhere around 300 or 250 ohms. So the same thing what I did for one LED, I will repeat it for second LED. This time, so this time, see, it's not that I will pick up always 13. You can connect it to any pin. So where will I connect? Assume that I will connect it to pin number 9 here, right? So what are the pins that I have chosen here? Pin number 13 and 9. So accordingly, the code has to be modified. So let us go to code. Can somebody tell me? So what is that I need to do? Again, I need to configure these two pins, pin number 13 and pin number 9. Pin number 13 is already written. The same thing I will repeat it for what? Pin number 9 here. Pin mode, you need to identify whether this pin is an input of Arduino or output of Arduino. Again, remember, Arduino is supplying the power to the LED. In that case, it is output port from the Arduino perspective, right? So in that case, which pin I'm using? Pin number 9. So what is the mode? It is output pin, right? It is an output pin. Since I'm using 2 pins, I have made that configuration now. Now when I go to this loop, what is that I need to do in loop? Again, I need to write a piece of code that will control these two LEDs, right? So initially we will try to have the same functionality for both the LEDs. What will I do? See, I have written pin number 13 with a value of 1, right? That means it is going to be on for some time. Then what is the status of the second LED? Let it be on, right? So let us turn and turn off LEDs at the same time. Now notice what will I do? Digital write. Digital write means send a value of 0 or 1 using these functions called digital write. On which pin number? Pin number 9. What is the value that I want to set? Let it be high. Then on the second line, after a delay, what will I do? I will again write this function called digital write. On pin number 9, keep the value as low, right? Keep the value as low, right? So maybe initially I will, keep these delays as same. So what we have done, we have taken two LEDs. So initially they would be on. After some delay, that is after 2 seconds, I will turn both the LEDs off. Run this now. Check now it works, right? It is simple. It will start working. You can see both LEDs, so turning on and off at the same time. Is there any error? So is there any error as such? Okay, let me know. Any error? Any error? So since I have shared, I cannot see this bottom of my screen where I can pick the error here. Just give me a second, right? So pin number output, it is there, digital write 13, then high, digital write 9. So this is also high, and then 2. Okay. So simulation is not started. There is something wrong here. What is that? So digital write, delay, then digital write. Pin mode number 19 we are using. Okay, this is fine. So this is 330 ohm. This is fine. So okay, let us go to code again.
Can you
So
try to
loop
09?
Sorry, no, it's not
09.
that. So
Oh.
no, it's not that. It is basically the spin. So if that is okay, say this window is compressed. So I'm just checking if I can see this error message, which is not happening. So if that is the case, 09, we will get the error directly here. It will not be on this line number 8. Okay. Just give me a second. Right. Okay, he says, okay, so he's requesting for 09. So let us, give him that interest. So if you check, check if it happens here. Okay. Yeah, see now, so this has nothing to do with the 09 because you just need to mention this 9 here. So somewhere something is wrong. We just need to look into this, right? So pin mode, so 13 and then output it is written. So check if all braces and then these semicolons are written. So you have wide loop, digital write. So high, then delay, digital write, right? So check the spelling of these functions. Digital write, you have digital write. right? So pin number 9 and then low, this is
So
right
the
here.
pin number 9 is -9 that is written in the picture. So does that have
Okay,
any
now it is
implication? Can you change it to 8?
Alok Das.
Yeah.
So, sir, sorry, you were saying something. I didn't hear you. Can you come again?
Can you change in the second connection to pin number 8?
No, no, that should be fine. It doesn't make much of a difference because D0 to D13, all pins are your IO pins, right? So maybe I think your concern is that since it is a pulse width modulated signal and it may not give you the right result. Is that so?
Yeah, maybe. Yes.
No. So see, when you want to, use them as pulse width modulated outputs, you possibly have to use a different function, and it is going to be an analog function, right? So otherwise, you can use any pin right from D0 to D13 as input output pins, right? So now I think maybe with the same pin I have done the simulation, it is working. So you can see both the LEDs turning on and off now. Okay. So there is no problem as such. Yeah, you can use pin number 8 or 9. Anything is fine. So because all D0 to D13 can be used as input and output. So digital input and output. Okay. Right. So now I think maybe there was something. So we just, try to find it. So once I did the stop and then start the simulation, it is working fine now. So, right. Both LEDs blinking at the same time, right? So it is just fine now. So now with this small experiment, what you can do is you can always, change these little sequences. This is just to play around with, right? What I can do, I can keep one LED high, I can keep one LED low. Then what I can do, 13 is high and then 9 is low. And later you can, send this 13 to low and then you can change this to high, right? So now this way you can always see that one LED goes on and the other one is always off, right? So it is mutually exclusive, right? So one goes on, one goes off. So this is how it is done. And now you can always add a few more such things, right? You can always add a few more LEDs and you can keep working on that. And don't expect that I just keep on doing all these things, including, 14 LEDs as such, right? So now if I can add one more, this is just for the sake of, some learning here, right? So I will pick up one more LED and then I short their ground. So I will connect this resistor here. You can keep it resistor here. You can connect it to any pins, right? So now if you do this, right, again, change the color. So just indicating that it is powered now. So what can be the code here, right? I'm sure all of you can now write this, right? So you can pick up the same text here, copy this and paste it, change this pin number to what? Pin number to 7 here now. This is done. And then similarly, you can pick up this function that is called a digital write, and then, add this. So which pin number? Pin number 7 here, right? So you can do this. And also, right, at the bottom, I can write it. You can either keep it to low or high, whatever it is. Any combination that you want to write, you can do this, right? So just run this now, right? So this goes on. So with LED, you can keep on doing this, right? So some operation we are doing here. So something is, is 13 high, low, low, and then pin number 13 is low, and then this is okay. Pin number 9, so sorry. So there is this pin we need to change, right? So this make it as 7, right? And then this I can toggle it to high, right? So this will give me some combination of LEDs turning and on. Now, why I have given this 3 LEDs here is, see, once you look at this, right, can you write a function called a 3-bit counter? Something that we have studied in digital design, right? A 3-bit counter where initially everything is low, then gradually, the sequence states changes, right? So similarly, if I have to design this, I don't do it. You can possibly do it once you finish off the session. So now initially everything is low, then what? Only the pin first one goes high, then this can be low, and you can just keep on playing around with this so that you can see that you build a counter around this, right? So low, and you can see a small change in the LEDs. So you can just copy this. You can keep on changing this, right? So I will leave it to you. Possibly after this session, you can just work around and you can build a counter around this. You can build a 3-bit counter, you can build a 4-bit counter, and then so on now, right? So you can just keep on changing this. It is a very simple program to work with, right? So high and then low. So start the simulation. Okay, so 3 states here. So this is 0, 1, and then a value of 2 again. So delay is missing. So the delay after the last statement is very, very important. Otherwise, you will not be able to see the changes here. So this is very, very important that we include a delay here, right? So now, so with this, 3 LEDs, you can see that as the number of LEDs are getting increased, the connection looks, bit more awkward. So you can always have a better way of connecting them, right? So you can complete this code, right? So if I keep on adding few more resistors here, now I can pick up one more resistor. I can keep on adding this, right? So that way it looks, very, very odd that you are keeping these things and connecting the resistors and the wires become very, very, uh, it gives you a circuit that is bad looking. So in that case, what will I do? I will basically, this wonderful component that is there in electronics that is called the breadboard, right? So with the help of breadboard, I will make some, connection that looks very, very organized, right? So that is precisely the reason why we go for a breadboard now. So if I have to do the same thing using, the breadboard, so let me show you how to, use breadboard in this particular setup here, right? You can delete all those things and then you can use this breadboard and you can make these connections, right? So even this online tool Tinkercad comes with this board called breadboard. Now you click on this breadboard and place it next to the Arduino. So once you do this, it will give you a very good looking circuitry. So this is something which you can easily understand. So what I do here is, right, if you notice, so you have this, rows written with the minus, and then you have this, these holes marked as plus. And then at the same time, you can have the similar things at the bottom now. So what will I do is any minus that is there, I will make it as ground. Anything that is written as plus, I make it as a power, right? So now since we have to get this ground and positive supply from Arduino, so ground, I will connect it here to minus and then change this color to black, right? What has happened now? So this entire row start working as a ground here, right? And then from this minus to this minus, I will run one cable, right? I will short them. Now, what is this? So this entire row here and this entire row is acting as ground now. Similarly, I will pick up this 5 volts, right? I do the same thing here. So I will connect it to this row marked as plus, right? So change the color wire, right? So you can make it as power now. So this entire row is giving me 5 volts, and the same thing I can extend it to the next row also, right? So this way you can have, a flexibility of making ground and then the power connections here. Now, what is that we are doing? So we can just pick up these, LEDs here. You can easily now, take them, right? So I can place one LED here. I can just hit this option, zoom to fit. So it will, see, it will give everything within this now, right? So I can copy this LEDs. Instead of choosing there, you can keep on copying this. So I will create one more copy of this. There are 3 LEDs now. So if you want, you can just keep the change the color of each of these things. You can do this, right? This is done now. Now notice. So since all these things have to be connected to ground, I can just extend it and then I can easily connect them to ground here now. So this option you will get, right? It is a good thing that you have this, right? So you pick up this, make it as black, right? Every cathode, just run it to this line where you have a, right, the ground now. Then pick up one resistor, right? So pick up a resistor. So take this, and there is option to flip this. You can always rotate this. Use the symbol, it will give you a rotation now. So you can connect it to this. So what is the value? I can always pick up this as 330 ohms, not kilo ohms, just ohms. And then, so from here, I can connect it where? I can connect it to any pin. I will connect it to pin number 2, right? I can connect it to pin number 2. Then pick up this resistor, copy and then connect it to this. You can use some other pin to work around with this. From here to here, I will make a connection. From here, I will run this. I will connect it to pin number 3. And then from here, you can connect it to the resistor, and the other end of resistor, you can connect it to pin number 4 here now, right? So this is what the connection is. Now, if I can go back to code, right? So since you have included the breadboard, nothing is going to change in terms of code. It is just an additional component where you can organize your circuit in a much better way, right? So what are the pin that we have chosen? See, 2, 3, 4. I can just change it here, right? I can make it as 2, and I can make it as 3, and I can make it as 4 here. And see, if you notice here, since it was 13 earlier, I'm changing it to 2. And wherever you have written 13, you need to go and modify that. So this is very time consuming. If you have written this 3-bit counter, and if you have, created these sequences of LED turning and on and off, going to every line, modifying the value or pin number, consumes a lot of time. So in that case, what will I do? So I will use something called as the symbolic constant. We call them as the preprocessor directives, or we call them as macros, right? So I write this as hash define. What is it now? So what is that I want to do? I want to use this pin number 2, 3, and 4. Where this red LED is connected to, red LED is connected to pin number 2. I will write something called as red, and I make it as 2. Now notice. So red is a constant, which is same as pin number 2. Similarly, I will take one more macro hash define. I can call it as so in this case, it is brown, right? So I can simply write it as BR. Where it is connected to 3. Then I have hash define, right? So what is this pin now? This pin is basically green, right? I can write it as GR here. So then this would be what? This would be at pin number, sorry, I just changed the order here. So this is what, this is 4, this is 3, this is 2 now, right? So now what will I do is, here instead of writing these numbers, I will simply write it as a red, and then I will put the symbolic forms, right? So I will tell you what is the advantage in doing this, right? So you just need to write them once. Even if you want to change the pin number later, it is going to be simple, right? So what is this now? Pin number 13, I will make it as red, and then I will make it as brown. Then this is going to be green, right? So here it is red. So only once you need to write this. So this is going to be BR, this is going to be GR, and then keep modifying this red, and then this is brown, right? So it is a one-time convention that we need to follow. Now what has happened? Look now. So tomorrow my mode changes. Instead of, picking up this pin number 4, I will make it as 13. If you have defined these macros, remember the advantage that it offers is, right? So since you have already written the symbolic, representation everywhere, you don't need to go and modify this. You just need to modify this at one place. So from 13, I will simply make it as 14. So automatically, wherever you have written red, everywhere the value is modified as 4, right? So this is called a macro. This is a very useful feature in C and C++ programming, right? So if you have to substitute the same value at multiple locations, you create a macro, and with that you can easily do it in one single step, right? So now if I start the simulation, what will happen? So the result will remain same. You can see this, the LED is turning on and off in some sequence as per the values that we have written, right? Is it fine? Is it fine? So we are just, doing it in a very systematic way. So this is called, controlling multiple LEDs through the Arduino now, right? See, please notice your circuit connectivity has to look good, and at the same time, the code also has to look good, right? So it is always a better practice that you make use of the macros. They will always simplify the coding, right? They will always help you to, simplify or basically save a lot of time when it comes to writing the code, right? I hope this is fine. Right. Now we have we had too much of discussion on, so Alok sir, want to say something? Okay, fine.
Yeah, we
So
can break for a minute and take some question if anybody have any question.
yeah, I want
Then
to wait,
probably you
sir.
can.
So now, so the discussion and LED is done with. Now I want to have the questions, right? So then gradually we will
Yeah.
move on to some other topic. So anyone
Okay.
with any
So
questions? Skandya, Gauri,
you can
right?
type it
Any questions?
in the QA box or in the chat box, and I'll read it out to the presenter.
Any questions? You can just post it in the chat box. Any questions? Any questions?
So one question I saw earlier in the towards the beginning. So they are
Okay.
asking for books. So if you can suggest any books on top of your mind.
Okay, see, as far as Arduino is concerned, it is very difficult to find a book. All you can do is you can just log into the Arduino development page. You will see a plenty of documents there, right? So there is a user manual, huge user manual where everything is explained well, right? How to use a specific when, what are the different functions that are available. You can always log into this Arduino website and you can read a whole lot of things. So what I can do is possibly I will share you the link of that. You can refer to some of the documents. And as far as working with these other components is concerned, so maybe I think going forward we will discuss few more components. So that we need to read it. So possibly you can now assume that if I want to work with ultrasonic sensor, you can just type this particular title in Google and you can see a plenty of information available on that. So as far as Arduino is concerned, so you just need to use you need to use the pin diagram of the ultrasonic sensor, understand how ultrasonic sensors work, and then accordingly you need to code. Right. As far as coding is concerned, so this particular Arduino is based upon C++ coding, and I think maybe even with a little bit of coding knowledge on C or C++, you can still manage it. Need not necessary that you should always learn C++. You can begin with C because all these are built-in functions. You are just using the built-in functions, so there should not be much of a problem as far as learning C is concerned. As I told, you can begin learning C programming by choosing H1 Kanetkar. I'm sure every single library in college has got this book, right? A good book to begin with. Once you become better at programming after reading the H1 Kanetkar book, you can then move on to Dennis Ritchie, right? It is a wonderful book to read out. So Dennis Ritchie, I think maybe if you read for 4 or 5 times, I'm sure that even you will end up cracking all your placement exams that comes on, C programming. Right.
Okay. So few more questions have come in the chat box. Let me read it out for you.
Yes, sir.
One important question I can see is, can I use Arduino as emitter?
Sorry, sir. Can I use?
Arduino as emitter.
Sir, can I use Arduino
Emitter.
as a emitter like in micro emitter? Okay. So this question is coming from Mithun Gowda. Right. So Mithun, you cannot use Arduino as a emitter, right? So what you can do is you can build an application so that you can basically mimic the emitter as such, right? So, but now if you have to, tell, so you can also use emitter because emitter is basically, you get these two probes and you can put it at some points and it will read out the readings as such, right? So you can use emitter on any pin of Arduino, but using Arduino as emitter, I don't think that that is a possibility as such, right? So you can basically design a function. What you can do is you can possibly design a small application where you pick up LCD and then you start coding such that it will give you the emitter like reading as such, right, Mithun?
So another interesting question. I like this question.
Yes, sir.
Can you tell about something about the loading? This is the question. Maybe I think who has asked it is concerned about you are adding 1, 2, 3 LEDs, and maybe if he has in mind, if I add more LEDs, what will happen? Will Arduino be able to supply? Maybe he's asking this.
Okay, so right, in fact, it is a very, very good question. See, there is again going to be a limit to how many LEDs you can possibly add. So, so you have these 14 pins to work with. So as far as the digital outputs are concerned, so then definitely, there comes a loading problem because, so as you keep on adding the LEDs and then, the current keeps on getting divided, right? So that way there is always limitation, and that is the reason. So there are always application that come with some external supply also. Only thing is that we use them to control from the Arduino, and then the supply to them will always come from the outside. I'm not sure
I
who
think that's all.
asked that question, sir.
Let me go back and
Okay.
give me some time. This question was from Rahul Malhotra.
Yeah, Rahul. Is that fine, Rahul?
I don't see any more questions, so you can carry on.
Okay. So, yeah. Okay, fine, sir. So again, so I think we have one more hour left in between. If you have any questions, you can please always put that across to us. So we will try to read as many questions as possible, and then we take on more questions as such, right? So Rahul says, okay, so he's happy. He posted a message that you answered it well. Yeah, thank you, Rahul. Right. So now, okay. So what we will do is, it's been a lot of discussions centered around the LEDs. Then possibly we will move on and we will see some other things also, right? So what is that now? So again, so remember whatever I'm doing. So I'll possibly convert it into a PDF and then I will share you. So I think I'm sure you might have been a part of some of the group where this webinar posting is done. So you will get that document through the coordinators, right? So, okay, right. So then what we will do is we will try to add a few more components to this. Now, what will I do? So we can just get rid of these things, right? So I will bring in one more very simple but very useful device, right? So that is sensor now. So I will try to work with this little sensor here. So what is that? That is called PIR sensor, right? Okay, just give me a time. Right, it is. So deleting is one big thing that we need to maybe consider here, because we are just using the same circuitry, and then I will keep on modifying this code, same code over and over again. So what will I do is I will bring up this PIR sensor here, right? A very good sensor, but a very, very simple sensor, right? So a PIS sensor is basically called as a passive infrared sensor. What it does is, so it has a certain range, right? Within that range, if any movement, any human movement, or for that matter, any animal movement happens, so it will be able to identify that movement. Hence, it is called as a motion sensor, right? It will try to identify the motion of the living objects. Remember, again, it is living object. The reason is simple. See, every animal or a human being, whenever we move, we will emit a sort of heat waves. So that would be sensed by this particular IR sensor, and then that way it will generate a signal, right? So we need to read out the signal whether it is set to 0 or 1, and based upon that we need to write a code such that it indicates that whether there is a motion or not, right? So if I have to, okay, there is a small, presentation included in this. Now, maybe if I can go through this, right? So I have created this PIR sensor diagram here. So you have 3 pins connected here, right? One is ground and the other one is VCC, and the center pin is an output, right? Either it is going to be 0 or a value of 1. Again, so since it is 0 or 1, any sensor that gives the reading in binaries, right, definitely has to be a digital sensor, right? So it is famously or called as motion sensor or a motion detector sensor now, right? So as I told, it basically, has a certain range, right? Assuming that this is the range, any living object, whether it is a human being or animal, shall cross or come under this particular, region, then this particular movement will be recognized by the sensor, right? So again, so as I told, only when you move, only when there is a motion, so it will detect that motion. If you enter a region and if you stay there for a longer period of time without making any movements, it will not identify that. Only if there is a motion, it will detect that, because it works on the concept that whenever a living object moves, it emits a heat wave, and that it captures and then identifies that there is a motion now, right? So not thank you. So this is the slide that read thank you. So not as far as the session is concerned, right? So now what we do is we will write a small code here. So what is that? So there is a signal, there is a power, and then there is ground. So anything that has a power, it should go to what? It should go to the power pin now. So the positive voltage. Where will I connect? I will connect this to this red terminal here. So indicating that I'm getting power here. Then what will I do? I will, pick up this one more pin called ground. I can make this connection here where we have taken this row as ground and will write it as black now. And then, so it is powered now. So anything, any movement around this region, it will make this pin signal to either have a value of 0 or 1. Remember, any movement it detects, it will send a value of 1. And any time there is no motion, it will leave out a value of 0. So this signal should be connected to any of the digital pins. Assume that now I will connect it to pin number 3, right? So I will change this color to something else. Let me make it as green now, right? So go green, correct? So signal is connected to pin number 3 here. So how it works, it is simple. We will turn, since it is powered, it is on, it will sense the motion. If motion is there, it will turn this signal pin to 1. Otherwise, signal pin is always 0, right? So let us go back to our code, then we will try to work it out, right? So what will I do is I will just comment this whole code. I will not delete anything that I write. I will just use this, right? So this is commented. In that case, this is no more valid now. So I will begin everything from the scratch. So what we need to do? So as I told, we make a habit of using these macros. I call it as hash define. Which pin I'm using? I'm using pin number 3. What is that I'm using? PIR sensor. I will write it as hash define PIR as a value as a pin number 3. Now please think and answer this question. So I'm setting up this pin. Which pin? PIR pin. So now, is it an input pin or is it an output pin? Should I declare it as input or should I declare it as output? Can somebody tell me this? Pin mode. What is the pin mode? So now this signal is connected to Arduino pin number 3. Can I make it as input? Can I make it as output? All you need to understand is only simple thing. Whether the signal is going from sensor to Arduino or from Arduino to sensor. Just need to answer this. Signal is going from Arduino to sensor or sensor to Arduino, right? Here, this sensor will detect a signal, then, right? Then it will basically send it to Arduino. That means this pin number 3 is acting as an input of Arduino. So which pin? The PIR pin. Acting as what? It is acting as a input pin here now, right? This is done, right? So now what will I do? I build this particular function loop. So while all my functionality goes here, right? I can do this here. So pin number. Now, I'll try to understand. In case of LED, what we have done is we have, send a signal to LED, right? We have sent a signal to LED indicating that I'm writing something. I'm writing a digital value, 0 or 1, high or low, right? So hence we have used the digital write a value of low or high in a particular pin. Now in this case, what is that I'm doing? I'm doing the opposite operation. I'm reading the value from the sensor, right? In that case, I call it as digital read. Digital read. Read the value from which pin? From the pin that is declared as input now. Here it is declared as PIR. Correct. So now, so this signal pin, this PIR pin either gives me a value of 0 or it gives me a value of 1. How do I know that this is a 0 or 1? Right? Hence, in that case, I will take this variable called PIR status. Right? So I check the status of this sensor now, whether it is giving me 0 or a value of 1. I take a variable called PIR status. This PIR status is either equal to 0 based upon what is the value that we are reading, right? But notice here, PIR sensor is a variable, right? It is not a keyword. In that case, I need to declare this, right? What will I do? So here I will declare as int, right? Int PIR status, right? So this is, right, a variable here. So what PIR status will do, it will collect the status or value from PIR, which is either going to be 0 or 1. So then what we do, we apply this simple conditional statement here. If PIR status, right, PIR status is equal to, right, high. If PIR status is equal to high, what is that I will do, right? If PIR status is equal to high, what I will do, I need to have a mechanism where, I will check whether it is high or not. So how do I check now, right? How do I check? So can I take one LED there? Yes, you can take one LED, right? If PIR status is high, I will turn on the LED here now, right? So I can write digital write, right? So digital write on pin number what? You can pick up any pin number. I simply call it as LED and I say get this value of high. Otherwise, else, right? So if PIR status is not high, that indicates that it is low, then I write digital write, right? So I can write digital write on pin number what? On again LED. LED is a macro. I will soon declare this now. This is done, right? So here I don't need to use a delay here because I'm not doing any sequential activity that after this has to happen. No, we are just checking the status. Based upon that, we are determining whether the LED has to be on or off, right? So what will I do? I will declare one more macro here, hash define, right? This time it is LED. Which pin number? You can pick up pin number 13 here, right? And this has to declared here pin mode. I need to write what is this? This time it is LED. So this has to be an output pin here, right? This is done. So what is done? So PIR declaration is done, LED pin declaration is done, input output declaration is done, and logic is also written here now. So, but I have not connected this LED as it. I can pick up an LED here, right? So pick up this LED and keep it somewhere here. I will keep it here now. So this has to go to ground. So I will ground it, right? So maybe I can connect it here, turn it black, then pick up one small resistor with a resistor value of, 300 ohm or somewhere around that, right? So pick up this resistor, connect it here. So change it value to 330 ohms, right? So I can make it as ohm. So I can connect it here, right? So this has to be, okay, this should go to some pin, right? Which pin? So pin number 13 I have taken here, right? So pin number 13 I have taken here, I will connect it to this, right? So just to distinguish it from power and other things, I will make it as green, right? Okay, this should be fine, right? So let us run this, right? Let us simulate this. I will do a simulation here, right? See, if you notice, simulation is running. That means the circuit is active. How do I now check this, right? So all you need to do is take your mouse pointer and, click it on this, the dome shape of the sensor, right? You can see that there is this range, right? As I told, this sensor has a certain range. Only if the moment is within that range, you will basically, identify this, right? So now I have told also one important information that, see, this now round, structure is acting as a, a living object. When it moves, it will emit the heat wave and that will be sensed by the sensor. But now it is in only one single location. Since it is in single location, there is no movement and this is not recognized by sensor. It indicates that there is no motion, and because of that, it is giving me a value of 0. If I now move this, right, since there is a movement, it is going to generate a logical value of 1. And you can see when there is a movement, the LED is turned on here. Can you notice this, right? So when I move this, the LED is turned on. And once I keep it idle, right? So, second. So why? So okay, it is going off. So, right, let me have the code also. So PIR status, digital read PIR pin, if status high, LED high, otherwise it is low. Okay, that should be fine, right? So now what is happening here is, so when I click on this, now notice this is in one position. It is not moving because of the LED is off. Now run this. Just move it once, leave the cursor. You can see that the LED is on for some time, right? Then gradually it goes off, right? So it will recognize this activity for some time and it will keep the LED on. And once it settles down, after a certain period of time, it will again, make the LED off. So because the particular, object is at one single position. And also remember, so outside this range, right? Outside this range, any moment the sensor will not detect this. Now it is idle state. Any moment that is outside this range, right? So I will not sense, right? Anything that is going outside is not sensed by the sensor. Only in this given range it will work. Now if I move this within this range, you can see the LED is blinking now. LED is turned on. Correct. Is it fine? I hope all are okay with this, right? Rahul says yes. Anyone else? So is it okay? Shomano says yes, right? So I see this nice thumbs up coming all the way. So this looks good, right? So this looks good. So it is a very simple application. We have a sensor now. So based upon the sensing capacity, you can always turn on this light, right? So now you might have seen this automatic door opening in some of the malls, right? So the moment you go closer to the door is automatically opened. Now you can guess what is happening there, right? So you can guess what is happening there. Here I'm just, so once the motion is detected, I'm turning on a LED. So you can create some noise also anytime. So assume that if you're not monitoring something, if somebody turns up at your door, right? So if you have a motion sensor, it should identify that motion and it should turn on some alarm, right? So we call it as a buzzer now. Can I include a buzzer here? Yes, we can include, right? So we can include a buzzer to this particular setup here. So what will I do? So along with the LED, I will connect one buzzer here. So what is that now, right? So this buzzer I will include here, right? See, it does all combining various things together to build up one application. This is my buzzer. Now, how it works? It is simple. See, it has only two terminals, right? So positive terminal should be, connected to positive voltage and negative should go to ground, right? Whenever there is a voltage difference, it will basically turn on. So this I will connect it to ground, right? So this is now grounded. So let me make it as black. Then what will I do is, so this positive terminal, I will connect it to one more pin, right? The way I have connected LED, I will connect this buzzer also, right? So now this buzzer is connected. Let me make it as a red here, right? So where is it now? At pin number 12. So go back to your code. So can somebody guide me? So what does that need to be done? I will again create a macro for this, hash define. So what will I call it? So what is this? This is a buzzer now. I will call it as buzz, right? So you can call it as buzz. Which pin number? So pin number 12, right? So then I can include it in my setup here. So what is the mode of this particular pin? Is it an output pin or input pin or output pin? Again, same. I need to identify whether, buzzer is giving the signal to Arduino or Arduino is giving signal to buzzer now. So now the buzzer is getting signal from Arduino, right? In that case, it has to be what? It has to be the output pin. So what is the name? It is buzz, right? So comma, then followed by output here, right? So what will I do? So wherever you have written this LCD pin, right? Sorry, LED pin, I can include the buzzer there, right? So I can write digital write. So parallelly, we are turning both the things, right? So here it is buzzer and then followed by high, right? So this is high, and you can use this braces here. Remember that in case of C programming, if you want to execute more than one statement, you need to necessarily include them within pair of braces, right? So if there is only one statement to be executed, you can optionally leave out the braces. But if there is more than one statement to be executed, you must always write the braces here. Now, initially we had only LED, hence I have not written the braces. Now I have braces written because both LED and buzzer are being written too, right? So even in else statement, I need to have two statements here, right? So I will write digital write LED and digital write the buzzer here now. So both will get the same thing. I can write it as buzzer here, right? So high and low. Now let us check if it works. Okay, I need to close this brace also. Now let us run this, right? So simulation is active. Now I need to, check whether there is a motion or not. If I click on this particular sensor, since the object is at one point, there is no motion. Now if I move this, right, the LED is on and also this buzzer is making this noise here. I'm not sure whether you can hear the noise. So in my laptop, I can hear that. So can you hear this noise? The buzzer making some vibration and there is some noise coming out of it. How many of you hear this? Yeah, Nitin says he can hear this, right? So I can just, make this motion here and you can see that. So you can see this buzzer start vibrating and along with that, there has to be some noise, right? So now what is happening here? It is a simple application, right? So we have built a simple application where I have connected one PIR sensor and then one buzzer to Arduino, right? So you can build one small application here, keep the sensor at your door point, and the moment you anytime going in and out, so the sensor will sense that and you can turn on this buzzer, right? A simple application, right? So based upon the human motion, you can turn on the buzzer here, right? So this is done now. So any questions here? Anyone, any questions? Okay, if there are not any questions, so I'll just move forward now. So with that, again, we can pick up some component and then we can see if we can. Is there any sensor which can detect only human motion? Okay. So see, there are plenty of sensors available. You can just, possibly do a little research on this, right? So there are so many sensors available that at times you may not be able to even know or even know that there exists such a sensor. In that case, what you can do is you can possibly do a small Google analysis there. You can just make a list of all the sensors available and then you can start using them. So every sensor will have the a similar thing. So either it can be a digital sensor or an analog sensor. You just need to identify and accordingly you can write, right? So I'm not sure who asked that. I think it is Pooja. Pooja, you can always look for a different type of sensors, right? So where only whether the humans are recognized, right? So every day these days, so many sensors are coming up, right? So we can always expect such kind of sensors to be available. Okay, so I lost one question in between. I don't know. So there is something related to AI. Alok sir, I'm sorry on your behalf. I'm reading all the questions that are coming my way.
Sure,
Right.
sure. Please go ahead. No problem.
Yeah. So we can.
There is
Yeah,
a question. Can I add one more buzzer?
Okay, so you can use as many buzzers as possible. So because you just need to understand the capability of a particular controller, how many devices it can support. Now, if you look at this case, see there are so many empty pins available, right? When you can connect one LED, two LED, three LED, and so on. Similarly, you can connect any number of buzzers here. So it might happen that, see, maybe if I have to give you a simple example here. So, see, assume there are two. Nishant, can you just mute your microphone? Nishant is. Okay, I will do it from my end. So maybe Nishant is not aware that his microphone is turned on. So I will do it. Right. Okay. Right. See, now if I have to give you a simple idea here, can I use the two buzzers, two PIR sensors, or two LEDs? The answer is simple yes. So now, see, typically, if I have to talk about every individual residence, you have two doors, one at the back and one at the front. So I can set the sensor such that I will recognize whether there is a human movement in any of these doors, either at the front door or the at the back door now. So what you can do is you can pick up one more PIR sensor, right? So and in fact, this is the reason why I wanted to introduce you to this wonderful tool called Tinkercad, right? So one thing is that you don't need to spend any amount. So because this is online, and you can basically have a huge understanding about all these components, right? So when I can have one buzzer, you can just try it for yourself. Keep on doing this trial and error. Can I have one more buzzer here? Yes, you can. So can I also take one more LED here? Yes, you can take. So can I take one more PIR sensor here? Yes, you can take, right? So, and you can, write your program in such a way that, right, you have this, logic that will read the signal from first buzzer, and it will read the signal from the second buzzer, sorry, signal from the second sensor, and accordingly you can, turn on this second LED and second buzzer. So maybe just for the sake of simplicity, you can make it as some other color. You can just try this. So what you can do, you can, put it somewhere here, right? So you can rearrange these signals, right? So the only thing is that as per coding is concerned, also that have to be managed, right? So what will I do? See, this is positive terminal. I can connect it to pin number 11, right? So I will just give you a brief idea, and then later you can try to write the code. So this is the negative pin. This should be grounded. I'm grounding it here, right? So this you can mark it as black. And now see what it has to be. It is again one more sensor sensing the motion. It can be connected to any of the digital input pins, right? So I will connect it here just to identify that this is one more sensor. I will change the color. I will make it as purple now, right? So and this pin is power pin. This has to be connected to, right? The power pin, you can make this, and all power pins you can make it as red so that you can easily recognize them. And this has to be a ground pin. You can just ground it, right? So I can connect it to ground, right? So this is black now. So what is done now? See, sensor connection is done. Okay, only LED connection is left out. So I can connect this to ground here, right? So let us adjust this a bit, right? So I will place it here, right? So I can move this. Okay. So you can move this, so you can bring it closer to this, right? So this you can connect it to ground here. Okay, so one more resistor is required, right? So what you can do is you can do this resistor here of the same capability, right? You can connect it here, and from here you can connect it to any other pins here, right? And accordingly you just need to, modify your code such that you include all these things. I can just pick up this as yellow, right? So all this connection is done. See, what I've done is I have exactly replicated one more setup of the previous model. So once this happens, so now it is easy that you just need to have three more macros here, right? So under that condition, what will I do is I will simply make this as PIR1, LED1, buzzer1, right? What are the pin numbers you can identify? Similarly, you can copy the first three lines, add next three lines, and then you can keep on working that, right? So here in the first PIR sensor, I'm writing it as PIR status. Again, you can make it as PIR status 1, PIR status 2. So just you need to read two different values and it will work, right? So this way you will be able to have multiple PIR sensors and then buzzers. It's not only buzzer, you can have anything in multiples, right? So is that fine? I'm not sure who asked this. So I got this from Alok sir through maybe he has referred to chat window. So I hope this is clear, whoever has asked this question. Alok sir, any other questions in between?
just one interesting thing. Can
Okay,
we we can use AI to differentiate human and animal. Nikit has written that
Okay.
maybe in response to that question, which is asked that can we differentiate between human and non-human?
Okay. I think
So if you want to
Pooja
take
has
it, or
asked
if
me
you
this
can
question.
leave it also.
Okay. So Likhit has given me an answer. Can we use AI? Okay, we can use AI. In fact, he has given a solution to that particular problem. So Likhit and Pooja, these are two different aspects. So Pooja asked me whether there is a sensor which can, identify that it is a human or not. So Likhit has taken to a different field where you can use AI and then you can differentiate between human and animals. So possibly, so there are so many algorithms that are available in AI where we do this, a lot of object detection and all, right? So unfortunately, I don't belong to that particular, I don't have any knowledge on that particular domain. So, but what I can understand is, so there are something called as pattern recognition techniques where you will feed too much of data. As far as AI is concerned, it works based upon the data. You can feed in a lot of data where you try to provide the information to your algorithm such that you will pass as a particular feature of a human being to the pattern recognizing algorithm, and then based upon what feature it is getting to see, so then it will separate whether it is a human or an animal. But I don't think that this is a sensor. It is basically an algorithm that will make the distinction between animal and then the human based upon the feature it is able to read, right? So is that what it is, Likhit, right? So AI is not that sensor. It is basically the answer that is given is based upon the algorithm which gets the different parameters to look into. So based upon that, it will differentiate, right? So anyway, it is a good thing Likhit has given us one solution that we can use AI to differentiate. That we can always do, right? So I hope Likhit, what is this is basically based upon algorithm, you will be able to differentiate humans and then the animals. Is it? Okay, I'm not sure whether Likhit is there as such. Okay. So any other questions, sir? Okay, Likhit has responded that yes, sir. So do we have
No
any
more
other
questions.
Okay,
No more
fine.
questions.
Okay, yeah, thank you, sir. So, okay, so now what we have done is we have included these little sensors into our code, and then now can we use something else also? Let us see, because there comes a scenario where we possibly have to use a different things in embedded systems, right? So what I do is, so I have designed this. I don't want to delete this, right? So we can just go to this Tinkercad dashboard, and we can start creating a new circuitry, right? So you can go back to this and you can always build a new circuitry. So because I don't like to undo the things that we have already done. So, right. So you don't need to delete everything after putting in so much of effort here, right? So this is done. What I do? I will basically, pick up this Arduino. Now it is quite convenient to everybody. At least I guess that it is convenient. I can pick up this Arduino, then I can look for some other, components here. What I can do here is, so more often than not, there comes a scenario, you need to, control some devices using these switches, right? There is one switch called a slider switch, right? So it is a very, very simple, component. If you notice here, there is a small knob, right? There is a small knob, and if you look into this, so it has a terminal 1, terminal 2, and common. So what it means here is, say terminal 1 can be either connected to power or ground. If terminal 1 is connected to ground, terminal 2 should be connected to the power now. So it has to be, right? So any pin, just give me a second. I will just turn on my laptop charger. Okay. Okay, right. See, it is basically one of the pin to be connected to ground, the other pin has to be connected to power. And this common pin will basically give me the value of either 0 or 1, or positive voltage or negative voltage. voltage, right? So based upon this, we can again control some devices. So what will I do? I will again, so I prefer taking this breadboard. So, but for this example, we will avoid this, right? So this terminal goes to right ground here. One terminal I will connect it to ground. So let me take it in black, and then this terminal will basically give me this 5 volts now, right? I'm making this power connections. So let me call it as red here, right? So you can see this knob here. If the knob is towards a ground terminal, it gives me a value of 0 on common pin. If this knob is towards the red line, so it gives me a value of 5 volts, right? Again, it will give me 0 or 1. So where will I connect this? I will basically now connect it to some pin here. Assume that now I'm connecting it to pin number 3, right? So what I do here is, using the switch, I will try to control my LED here, right? Using the switch, I will try to control LED here, right? So maybe you can control LED, you can control buzzer, you can control the DC motor, you can use so many things. So I will use this now, right? So I will pick up this LED here. Okay, so this one connected to ground, right? So make it black so that it is ground. So then I will pick up one resistor here. So LED is now, right? So used in all the programs, right? Okay, so I will pick up this resistor here, change it to a small value of 330 ohms. Okay, then this can be connected to pin number 13 now, right? So a simple application is done. What is it now? So you just need to control this knob so that the LED can be turned on or off, right? Very much like the PIR sensor, whatever the code that you had for PIR sensor will still work for this code, right? So this particular application. Now what will I do? Again, I will pick up this text, right? So when I do this, see, by default, I will get this setup and wide. Every time you do this, you will get this, right? So I need this wide and setup. So anyhow, so this pin I will change. Instead of this, I will simply call it as LED, right? And then these things, we will come back to this, right? So what I do here is I will just declare this macros here, hash define LED. I can write pin number 13, then hash define. Which pin is this, right? So I'm connecting it to pin number 3. I can call it as a switch, right? Simple switch connected to pin number 3 here. Then, so the same thing, we need to identify here whether something is input or output, right? There are 2 pins we have chosen. Of course, LED must always be an output. And this time the switch is sending the signal to Arduino. In that case, this has to be input here now. So what is the pin number? Pin number is taken as switch SW now, right? So here what I do is I will remove the delay because we are not controlling this in sequence. I want them to be mutually exclusive when the LED is turned on, right? Okay, we will not use any delay so that at some time it is on or off. We will just try to control it through the switch here, right? So LED now. So what will I do? So same thing. I will take one integer. I can take it as a local variable. I can call it as switch status, right? So is equal to, right? What is that? Digital read. So digital read which pin? The pin number which is written as switch, right? You read this. If switch status, right? Switch status is again equal to high, I will do one kind of activity. Otherwise, else I will set it to low. Simple, right? So read the switch status. If it is 1, so then I will turn on the LED. Otherwise, the LED will be low now, right? So just turn on this. So they will do the simulation here, right? So now notice, look at the position of the switch. So simulation is running. You can check whether the code is running or not. So simulation time is active. That means it is on, right? So look at the switch. This switch knob is towards a ground pin, right? So in that case, what I'm getting is I'm getting a value of 0 on this pin, right? Since I'm getting a value of 0, switch status is 0. Hence the LED is turned off now. Now I click on this, right? So now if you notice, this switch has moved to the right towards the power cable. So terminal 2. So towards the red line. Since it is moved towards this, I can see that the LED is turned on, right? So you can just keep on doing this. Now it is shifted towards ground, LED is off, and then you can just switch to other position to turn the LED on now, right? So there are various ways in which you can basically control the LEDs now. So it is controlling the LED through a switch, right? Very much like what we do on our daily routine stuff, right? So we can just control with the help of the switch here now, right? So this is one thing. So what we have done, so we have studied the LEDs, we have gone through the PIR sensor, we have worked with the buzzer, now we have worked with a slide switch now, right? So now, can we do something colorful? So is anybody interested? Can we involve in something very, very colorful? So if you want something colorful, you can just give me a thumbs up. So we will do it, right? So yeah, Likitena says this, right? So what will I do is, so we'll just, okay. So I see so many thumbs up coming up now, right? So, okay. Right. So what will I do is I will add one more circuitry to this, right? So which is altogether a different component, but again it is connected to LED, but this time it is a different LED. I will remove this now, right? So I will remove this, right? So what I pick up here is I will pick up something called as RGB resistor, right? So this is a very, very, interesting LED here. So this LED is basically, LED that is designed by combining the, three LEDs, red, green, blue, RGB, right? So if anyone is from, the image processing background would be able to tell you that, so RGB combinations will give you different colors, right? So we will have different colors, right? So, but if you notice this, what is there in this component, right? If you notice this, one leg says red, so another says cathode, another one is blue, another one is green. So anything that is cathode need to be grounded. Straight away, I will connect it to ground here. Now, see, this is as good as saying that I'm working with the three LEDs in parallel, where one color is red, other one is green, the third one is blue now. So how about the connection to these things? Remember, the connection to these things is the same as that of your regular single LED. Right now, there is a red pin. So for this, I need to connect this resistor here, right? I will use a one resistor here. I will connect it here, right? So the value has to be again same. So I will pick up this ohms and I make it as 330 ohms, right? So now, so I will connect it to terminal 2 from here. So I will use 3 pins, 13, 12 and 11. So I will connect this to 13. So since it is red LED, let us make it as red. So I will copy this resistor, then I will connect it to this pin as well. What is this now? So this pin is say blue now. So this is blue, right? So this is blue where I will connect RGB. I will connect blue to 11, right? So I will now copy this resistor here, right? I can put it here. Then what will I do is I will connect it here, right? So this is pin number 12 now, right? This is pin number 12 now. Okay, right? So maybe, okay. So we will connect all these things, right? So the connections are done. Now 13, 12 and 11 are the pins here now. Okay, I'm sorry. So a small mistake is made here. What is that is? So in this case, I want to use this pulse width modulated signal because I want to provide different kind of values, not the digital values. So in that case, what we will pick up here is we will pick up something which is written this with a tilde sign here, right? You can see there is a tilde sign in front of, all these pins, right? Pin number 3, pin number 5, pin number 6, right? So 9, 10 and 11, you can see this tilde sign. Anything that tilde is basically represented as a pulse width modulated inputs, right? So in this case, what I'm doing here is, so I will try to provide different kind of values. It is not a constant value of 0 and 1, right? So this I will connect it to pin number 11. So this blue, I will connect it to pin number 9. And then I will connect to this pin number 2. Okay. This 2, right? Pin number 10 here, right? So I think we have a little time left. I think maybe we can finish off this particular experiment here, right? So the connection is done. So pin number 11, 10 and 9 are used. So let us go back to our code. So what we will do is, so we will now write this hash define. I call this as red, where red is connected. So identify the pin number. This is connected to pin number 11, right? So then there is one more pin. What is that? That is green now. I call it as GR, where it is connected. It is connected to pin number 10 now. So hash define, right? So where is it connected? So this is basically blue. I will write it as BL and I can write it to 9 now, right? Again, the same thing, you need to declare these pin modes, right? So the red pin, which is it now? Again, it is an output pin. Similarly, you can do it for the remaining two pins, right? So I will write these two pins here. So what is this now? So this is my GR pin, right? So the next one is BL now. So any switch is not required. I will remove this, right? So, okay. Now wide loop. So within this, right? So what I do is I will make a different function altogether here. What is that, right? So we will not write a digital value here. We will write an analog value here, analog, right? So write the analog value, analog, right? Which pin number? Pin number red. What is the value I want to supply? I want to supply 255 here, right? So one more analog, right? So what is that now? This time it is green. So what is green? So GR now. So 255, let it be 255. Now one more value here. So what is it now? This is blue here, BL now. Okay. So let us run this code and let us check what we get, right? So try to check what is that you will see on the screen. So start the simulation. Okay, we are getting error. So wonderful, right? So wide loop, what does it need to have? So wide loop, wide. So is something missing? Okay, GR red. So analog right is not declared in the scope. What is that? Okay, so the spelling mistake in this case, right? So analog right. So just run this. Okay, in fact, I made this analog mistake everywhere. Analog, okay, analog. Okay, can you see the color of the light here? Right? So I'm not sure whether you noticed this. Now notice that you can see the filament inside, right? So this a little structure there. When I start the simulation, it is all going white, right? It is complete white. So because RGB, when you have basically 255 value, it gives me a white color. Now let us change this value. So let us now reset to, or basically change one value to 0, right? Red is having 255, GR is having, green is having 255, blue is having 0. Now run this. Check what will you get. See, the color is yellow now, right? So the color is yellow now. So what you can do is, see, basically you can provide a value between the range from 0 to 255 for all the three LEDs, right? Provide any value between 0 to 255 for each of the things. Then you change what kind of color you will get, right? So for every combination, you will have a different color, right? So now this is giving me, right, some kind of yellowish, but not exactly yellow, right? So you can change this value to anything. I will keep it as 55. Then you check what will you get, right? So it is giving me different colors, right? So you can keep on writing this, add, right, any kind of combination. You can add a little bit of delay everywhere, right? So you can say a delay of, say, 2 seconds here. Then you can keep on changing this combination so that you can get different colors on the screen, right? You can do it, right? So a small delay everywhere. Okay. Right, it is giving me two different colors, right? So this is the RGB LED for you. You can use it and you can generate any number of color combinations here. This would work, right? So since everything that has started has to come to an end. So in fact, I love to carry on and on and on. So because I'm really having a good time with you all, but unfortunately, so we are done with the session considering the schedule that we are given with, right? So I hope all of you have enjoyed or learned the, working with the controller and coding to some extent. By no way, this session is large enough to give you a concrete knowledge about everything. But we did a small attempt, getting you some practical session where you feel like taking on those controllers and then sensors and then possibly everything that is going to be a part of the embedded systems, right? So Likith says, where do you teach, sir? So Likith, I teach more often when I get such opportunities, right? So apart from that, so I work as a, full-time employee of my own company called Cleverbit Solutions Private Limited, right? Anytime you are free, the office is located in Bangalore. You can walk in, you can meet me. We will see what we can learn together as such, right? So a very interesting question, Likith, where do I teach? Right? Whenever I get an opportunity, I will always teach, right? So somebody is asking, so whether the breadboard is required. See, breadboard is not essential all the time. So again, you need to identify when you can possibly use the breadboard, right? So it depends. Maybe if the components are getting too many and if the connection is getting little complex, then possibly I will go with the breadboard. Otherwise, not required. For small applications, you don't need it, right? So it is always nice to have if you have a complex circuit. So any questions? So I think we have maybe a couple of minutes left. In case if you have any questions, please do let me know. Yeah, thank you. Sarla says thank you very much. So Sarla, can I have your contact number, sir? Okay. So I will just I think request the program coordinator to put in my email ID, not the number, because if I share my number, I always get questions like, sir, what seminar seminar topic would you suggest, or what kind of project you want me to do? So I get a mail saying that, sir, can you send some very recent and good seminar topics? That is very, very difficult to answer, right? Seminar topic is something that you need to identify and then you need to work on that, right? So maybe not the phone number. I will share my email ID with all, so you can always reach me. So I'm typing at the space that is there for macros. You can use this, right? Vijay@gat@gmail.com. You can always mail me here, right? So I always try my level best to reply at the earliest, but even if it is late, but I will make sure that you will get the reply as such, right? So thank you. So whoever has asked me for my contacts. Any questions?
I think no more questions. So everybody is really, happy, and we had a really great couple of hours today night. And yes, of course, we wanted to go on the way you presented and the interactive simulation website, the Tinker, and that triggered a lot of interest in the participants. That I can see and everybody can see. So at a peak moment, there were around 200 participants, which is great. And I hope everybody enjoyed a lot. I have enjoyed a lot, and I wanted to go on, but yes, we have some time limit. So thanks, Vijay. Thanks for your time. Thanks for taking time and spending in IEEE webinar. Thank you very much. So I'd like to call Dr. Jalaja, if you want to tell
Yes,
something,
sir.
some closing comments.
On behalf of IEEE CAS Bangalore Chapter, I, Dr. Jalaja, thank Vijay sir for his wonderful presentation on this started embedded system. So if time permits, we'll arrange hands-on sessions on Arduino. So sir, can I know how you're giving hands-on session training on Arduino also?
Yeah, madam. So, I do engage in a lot of trainings where typically, I prefer, taking the students to hands-on. So simulation is one thing, and then actually working with the hardware is the other thing, right? So we will always plan. So we will have a discussion on that. So maybe once we go offline, we can always discuss and we'll see if that particular session can be extended to all the students.
Okay, sir. If time permits, like depends on the COVID situation, I will once again meet you on offline session itself, sir.
Yeah, we will do that, madam. I will be always happy in whatever way I can contribute and help the students to gain the knowledge. So I would always do that.
Okay, on behalf of IEEE Cash Bangalore Chapter, once again, I will thank Dr. Param, sir, for introducing you for the wonderful presentation. So, and also maybe our student has gained the knowledge how simply we can execute some embedded code, because in the labs and all we used to use some other technique, like we used to write for LED glow itself. We used to write lengthy program, embedded C lengthy program. Instead of that, how we can execute very easier manner that maybe they are come to know. Maybe it will helpful for their mini project as well as major project also. If time permits, we'll see in future also some more hands-on sessions. Thank you very much, sir.
Yeah, sure, madam. So I take this opportunity to.
Yeah, may I ask everyone to turn on your video so that we can capture this moment, and that will give a great feeling. Please, everyone, if you can turn on your video. Okay, let me capture Param sir. Okay, thank you everyone. With this, we come to the end of this session. We will have many more such sessions during the year, and wish you all a good evening. Stay safe and stay healthy. Thank you.
Yeah, sir, just before we wrap up, I just, want to take this opportunity to thank everyone involved. So I would like to thank all the students for taking their time off, because it is really difficult after, working through all your classes and then attending a session in the evening. It takes a lot of patience and then a spirit to attend such sessions. So at the same time, I would like to, extend my sincere thanks to all the CAS members who made this event possible, and especially my friend Dr. Parmesh Achari for inviting me for such a wonderful webinar. I thoroughly enjoyed the last 2 hours, and again, as I told, I would have gone on if the time permitted, but I would be happy to engage in whatever the opportunity that come in my way, right? So thank you, Jalja Madam, Alok sir, and then Parmesh Achari sir, and then everybody who was associated with the IEEE CAS Bangalore. Thank you very much.
Thank you, everyone. Thank you, sir.